Hey guys, welcome back to the channel. Today we'll be solving LeetCode 121, best time to buy and sell a stock. So we're given an array prices where the prices at the ith index is the price of a given stock on the ith day. So we want to maximize our profit by choosing a single day to buy a stock and then choose a different day and sell the stock. And we want to see what's the biggest profit we can achieve. So if you know anything about the stock market, you would know that you want to buy low and sell high. So we want to, for our starting day, we want to see if we can find the smallest price, and for the ending day where we sell, we want to see if we can get the largest price so we can get the biggest profit. So we can solve this efficiently in linear time using two pointers with a constant space complexity. To solve this, we're gonna have two pointers, a buy pointer and a sell pointer. The buy pointer is gonna start at the beginning of the array, and the sell pointer is gonna start at the second index. And we're gonna keep iterating as long as the second pointer, the sell pointer, does not reach the end of the array. And we're gonna have a results variable, which is gonna store the largest number we can find, or the largest profit, and to we don't want this pointer to pass this pointer, which won't happen. And one last thing, if the cell pointer ever reaches a point where the value at the cell pointer is less than the value at the buy pointer is going to become the cell pointer. So this can be better understood with this example. So let's get into it. So we start with 7 and 1, and we're going to calculate the profit. So our profit is actually going to be -6 because we bought at 7 and it ended at 1. But we're not going to replace the result with -6 because that's not larger than 0. So we're going to keep, so since this value is smaller than our buy pointer, the buy pointer is going to become the cell pointer. It's going to be go to that position, and the cell pointer gets incremented at every iteration. Now we do the same thing. So our current profit at this point would be 5 minus 1. So the value at the cell pointer minus the value at the buy pointer. So 4. And then we're going to keep iterating. This would be 3 minus 1, which is 2. We don't replace it because that's smaller. Keep iterating. 6 minus 1, which is 5. So we replace 4 with 5. Then we keep going. 4. 4 minus 1 is 3. We don't have to replace anything. And we are done. The result is 5, and we can return. So the time complexity of this is going to be linear. So it's going to be O of n, because we have to iterate through the entire array. And the space complexity is going to be constant because we're only storing 2 pointers and the result. To start, we're going to initialize our pointers. We're going to have a left pointer, which we're going to call buy, and it's going to start at the beginning of the array. We're going to have a right pointer, which is going to be called sell, and it's going to start at the second index. And then we're going to have a result variable, which will hold the largest profit we can find. And we want to keep iterating as long as the sell pointer does not reach the end of the array, so it's less than the length of prices. And at every iteration, we want to calculate the profit, and we're going to replace result with it if it's larger than the result. And we can do that using the max function in Python. And the current profit is going to be the price at sell minus the price at buy, like this. But if the price at the buy is larger, or if the price at sell is smaller than the price at buy, we want to replace it because we want to try to keep the smallest buy pointer we can with the smallest value so we can increase our profit. And then we're just going to replace it, and then cell just gets incremented at every iteration by 1. And after that, we can just return the result. So the question said that we have to return 0 if we can't find a profit, and this starts at 0. So if we can't find anything greater than 0, it's just going to return 0. See if this works. Looks like it worked. Thanks for watching, guys.